Hello children, welcome to Time. So today we are going to learn about metals and non-metals in our topic. So let us start our topic now. So going to metals and non-metals. We know that metals are from our ancient time. So the importance of metal dates back into the Bronze Age, where the first man started using the metals in the form of tools. Then slowly the metals have been utilized in a much better manner. So we are now having different type of metals and its alloys, and they have been a part of our kitchenware and of course in many industries also. So metals have been a major part, they are playing a major part in our today's world. Apart from metals, we are also having non-metals. So if you are taking our atmosphere, it is consisting of non-metals. So here if you observe in this picture, we are having many type of metals and also their alloys which are being used for making different things. Like if you see our utensils, our idols, our rims, our instruments and so many things. These all are nothing but they are made out of metals and their alloys. So first let us classify these elements. So getting back into the classification of elements. What are elements? Elements are the substances which are made out of one type of molecules or one type of atoms. So these elements are categorized into metals. So the best metal which we know from our ancient time is gold. And then it is also categorized into non-metals. So non-metals, we are having many non-metals around us like oxygen, nitrogen, hydrogen and so on. And similarly, we are having one of the non-metal like boron. So this is one of the non-metal. And it is also classified into metalloids. So if you are talking about metalloids, what are metalloids? Metalloids are the elements which possess some of the properties of metals and some properties of non-metals. Hence they are having both metals and non-metallic properties. So the example here is antimony. So antimony is one of the example of metalloid. So this is how we can classify elements which are in our world, means around us, into three categories, that is metals, non-metals and metalloids. Now, so let us learn in detail about these metals, non-metals and metalloids. So getting back into the physical properties first, because based upon the physical properties we can distinguish which is a metal and which is a non-metal. Hence let us learn the physical properties, and in the physical properties first is state and hardness. So if I am seeing the state of a metal, then I can tell this is a metal and this is a non-metal. So let us learn how the metals exist and how the non-metals exist and how is their hardness also. So first one is that metals are solids at room temperature. Only certain exceptions are there. So we are going to learn even the exception, but 90% of the metals are solids at room temperature. Like if you take the iron rod, iron is a metal, right? So you are taking example of iron rods, they are solids and of course they are harder. Right, metals are also harder because they are mostly in the solid state. But do you tell everything which is there in the solid state is harder? No. Now let us learn about that in non-metals. Mostly non-metals exist in gases, they also exist in the solid form. Okay. So here if I am taking the most of the non-metals like oxygen and nitrogen, that's why I have written mostly gases, but at the same time we are also having certain non-metals which exist in the solid form like phosphorus, carbon, sulfur, all these are the non-metals which exist in the solid form. Fine. So let us talk about the exception now. So when I am talking about the exception, before that as I am talking about the hardness, so we know that iron rod is hard, but if I am taking the gases, of course gases cannot be harder, but when I am talking about phosphorus or carbon, then are they harder? No. Phosphorus is not that harder because it is in a powdered form, or sulfur is also in the powdered form. Then how can they be hard like the solid state of metals? No, they cannot be hard. Now, but are there any exceptions? Yes. So let us learn about that exceptions now. So in the metals, most of them are solids as I told you, but there is an exception, that is mercury. So mercury exists as a liquid in the normal atmospheric pressure and temperature. At the same time, we are having gallium. So gallium is another metal which can exist in the liquid state. I mean to tell you that normally it exists in the solid state, but when I am taking that in my hand, it starts melting. So it has low melting point, that is at the room temperature. It starts melting at the room temperature. That is why it also can exist in the liquid state. So, talking about the exception in the non-metals, we are having a diamond. So, this is a diamond which is inserted in the drill bits. These drill bits are usually used for petrol mining. So, diamond is certain hard substance that it is used for used in the drill bits. So, diamond is an allotrope of carbon. So, what are allotropes? Allotropes are the substances which differ in their physical properties but possess same chemical properties. Since diamond is made out of carbon, so it is similar to the carbon in the chemical properties, but when you are talking about the physical properties, it is very harder. That is why it is an exception in the non-metal. In a similar manner, there is another non-metal that can exist in the solid form, that is iodine. If you see iodine, you see the state of the iodine and you see the state of iron. So, iron is much stronger than iodine because of the state, even though both of them exist in the solid state, but you can see it is not that harder, the state itself will tell us. So, this is how metals and non-metals differ in the state and hardness. Similarly, let us learn about another physical property. So, talking about the melting and boiling points. So, this is also a major physical property which will differ in both metals and non-metals. So, usually metals have very high melting and boiling points, but there are certain exceptions that we are going to speak about. So, if you are talking about very high melting point, iron. So, iron rods you have seen, they are very stronger and the melting point of iron is very high, that is 1538 degrees centigrade. So, it is very high. Now, compared with the non-metals, non-metals have low melting and boiling points. So, example if I am taking sulfur. So, the sulfur melting point is just 115 degrees centigrade. See the variation, there is a large variation in the melting points of metals and non-metals. Even though both of them exist in the solid state, but still you can see the variation in the melting points. That is why metals are much harder than non-metals. So, talking about the exceptions, so here we are having exceptions like sodium, lithium and potassium. These are highly reactive metals, that is why they are stored in kerosene. So, they are soft metals also that they can be cut with the knife. At the same time, they have low melting point. For example, if you are taking potassium, the melting point of potassium is only 63.5 degrees centigrade. Similarly, just now as we have discussed about gallium, so here if you are talking about gallium even though it exists in the solid state, but if you see its melting point is only 30 degrees centigrade, due to which if you are taking gallium in your hand, it starts melting. That is why gallium is also called as a liquid metal apart from mercury. Okay, these are certain exceptions in the metals. Now, let us discuss about the non-metals. So, if you are taking diamond has very high melting point, it burns before melting. Usually non-metals have low melting point and boiling point, but diamond is an exception that it burns before melting only. So, it has very high melting point. Similarly, if you are taking boron also is an exception because it also has high melting and boiling point. So, these are certain exceptions in the metals and the non-metals. So, let us go to the next physical property. So, going to the next physical property, that is luster. Luster is usually possessed by metals because metals are more lustrous. Now, if you are taking the example luster, the metals have luster, example gold, silver, platinum, all these, okay, they all have luster. Now, talking about non-metals, they have no luster. Right? If you take most of them exist in the gases, so of course there is no point of talking about luster only, but if you are taking sulfur, phosphorus also, they are also not lustrous. But are there any exceptions? Yes, there is an exception in case of non-metal, that is graphite. Graphite is lustrous, that is why that is an exception. So, graphite is also an allotrope of carbon. Fine. So, this is about one more physical property. Going to the next physical property, conductivity, malleability and ductility. All the three physical properties are almost related to each other. So, let us discuss about them. First is what conductivity. Conductivity means what? Conduction of electricity, at the same time conduction of heat. So, metals are usually good conductors of heat and electricity. And malleability. What is malleability? Drawing into thin sheets is known as malleability. Ductility, the property by which we can draw into thin wires. So, by now you have understood which elements, either metals or non-metals, are used for this purpose because metals. Fine. So let us see here. If you are talking about non-metals first, of course non-metals are bad conductors, that we know, and they are non-malleable and non-ductile. Why? Because most of them are gases, and the ones which are in the solid state also, if you see the state, that they cannot be drawn into wires or thin sheets. That is why they are neither malleable nor ductile, and they are also not good conductors of electricity. So talking about metals, we know that metals are good conductors of electricity and also are malleable and ductile. So let us see here copper wires. So copper wires are used for what? Electrical purpose, like electrical transmission wires, and the best conductor is silver. We do not use silver, the only reason is it is expensive. So apart from that, we are using copper, aluminium wires for the electrical transmissions. Now these are what? Aluminium sheets, right? They are malleable. Now talking about the exception, if you are talking about the exception, in which case is the exception? In both the metals and non-metals, we are having an exception. So first in metals, zinc. Zinc is a brittle metal, so it cannot be, it does not have the property of malleability nor ductility. Now going to the exception here, graphite rods. So graphite rods are exception in case of conductivity, because they are good conductors of electricity. So you know graphite is an allotrope of our carbon. So carbon form, if you observe, this is a form of carbon. This one I can, neither it is malleable nor ductile, but the allotrope of carbon, which is graphite, is a good conductor of electricity. So in this way, if you see, there are certain exceptions in both metals and non-metals. So going back into the next property, that is density. So talking about density, of course you have seen the state in both metals and non-metals, so you can easily identify which is denser. Iron, if you see the density of iron and mercury, iron is around 7.8 gram per centimeter cube, and mercury, even though it is in the liquid state, but still it possesses high density, that is 13.6 gram per centimeter cube. Whereas in case of non-metals, sulfur's density is just 2 grams per centimeter cube and phosphorus is just 1.82 gram per centimeter cube. See the variation, the liquid metal itself is more denser than the non-metals, solid non-metals. So in this case, if you are observing that metals and non-metals, the density of metals is much greater than the density of the non-metals. So going to the next physical property, sonorous. Sonorous means what? The property by which the substance can make sound. So where do we get sound? Like which substance if I am hitting I can get sound? Usually metals. You know our school bells are made out of metals or the alloys of metals. So metals are sonorous because they are hard. You take a metal scale and just hit on the metal scale, it starts vibrating. So when it starts vibrating, it starts producing sound. But if you hit on the wood, okay, wooden desk or something, then you do not get that sound, even though you get sound, but it is not sonorous compared with the metals. So that is a basic difference between the sonorous property of the metals. And if you talk about non-metals, so non-metals are usually non-sonorous. Okay, so they are non-sonorous, and if you take a piece of coal and hit on the piece of coal, it will break rather, but it will not make any sound. Or you take sulfur, sulfur exists in the powdered form, so there is no point of making any sound there. So in this way, if you differentiate, the sonorous property is only for metals, but non-metals there is no exception also in case of sonorous property. So this is how we can differentiate between metals and non-metals based on the physical properties, whatever we have learned in state, hardness, malleability, ductility, conductivity, sonorous and melting and boiling points. So we can differentiate based on all these properties. So I hope you understood the physical properties. Let us get into the chemical properties now. So let us discuss about the chemical properties of metals and non-metals. So based on the chemical properties, how can we differentiate between metals and non-metals? So the first chemical property is about number of valence electrons. So number of valence electrons can differentiate which is a metal and which is a non-metal. So how can we do that? If I am taking an element, in the element if you see the valence shell, so what is a valence shell? The last shell is known as the valence shell. So the number of electrons present in the last shell can tell us whether it is a metal or a non-metal. See, for that, if the number of electrons are 1 to 3, means either it can be 1, 2 or 3 in the last shell, then definitely it is a metal. Okay, for example, if you are taking sodium. So what is the configuration of sodium? 2, 8, 1, right. So, 2 in the first shell, 8 in the second shell, and last shell consists of only 1 electron. Since it is having only 1 electron, I can definitely tell that it is a metal. So, depending upon the number of electrons in the valence shell, we can tell whether it is a metal or a non-metal, and for that it should be only 1 to 3 electrons in the valence shell for a metal. So, coming to the non-metal, non-metals should have 4 to 7 in the valence shell, then only they are known as non-metals. For example, if you are taking chlorine. So, chlorine's configuration, if you are observing, in the first shell it is 2, second shell it is 8, and the third shell it is 7. So, 2, 8, 7 is the configuration of chlorine. So, it has 7 electrons in the last shell. So, 7 electrons is nothing but the non-metal. Hence, for non-metals we need to have 4 to 7 electrons in the valence shell, and for metals we need to have 1 to 3 electrons. So, depending upon the number of electrons, I can differentiate any element into a metal or a non-metal. I can distinguish any element into a metal or a non-metal. Now, going to the next chemical property, so that is formation of ions. Formation of ions depends upon the number of valence electrons. If at all I am having 1, 2, 3 electrons in my last shell, then they are metals. So, these metals can easily lose the number of valence electrons. So, if I am taking the formation of a cation. So, what is a cation? The element after losing electrons forms a positively charged ion. That ion is termed as cation. So, if I am taking an example of the same element, that is sodium. So, we know how many electrons are there in the sodium. So, first shell consists of 2 and second shell consists of 8 electrons, and the third shell has only 1 electron. Now, if it loses this 1 electron, then what happens? It is gaining a positive charge. Now, how it is gaining a positive charge? So, we have seen that the configuration is 2, 8 and 1. Now, after losing this 1, what is the configuration? It is 2, 8. So, after losing 1, it is attaining octet. So, octet is attaining, then what is the charge it is getting? It is a positive charge. How can I tell it is a positive charge? See, for example, it is having 11 protons and 11 electrons. Never the protons are lost by any element, because protons are inside the nucleus, only electrons are lost. So, here after losing 1 electron, so the number of electrons will decrease, that is 10 electrons. If you see the positive charge, that is 11 electrons, the positive charge is 11 protons. Now, which charge is more? Positive charge is more. How much? By 1 unit it is greater, hence it is acquiring the positive charge. So, that is sodium cation, that is monovalent ion. Okay. So, this is how we can tell about the formation of ions depending upon the number of valence electrons. So, for a metal, always the valence electrons are 1, 2, 3, means always they lose electrons to attain the positive charge and form cations. So, this is about metals. Now, going back to the non-metals. So, if you take non-metals, so as metals are forming positively charged ions, that as cations, similarly non-metals, since they are having the valence electrons 4 to 7, they tend to take electrons. Why? Because 4 to 7 are more number of electrons. So, what they do, they cannot lose. So, they try to gain electrons from the elements which are losing the electrons. So, here 1 to 3 they can easily lose, but 4 to 7 they try to gain those electrons. Hence, after gaining they form negatively charged ions. These are anions. So, let us take the similar example that we have discussed just now, that is about chlorine. So, we know the configuration of chlorine. So, it is first shell consists of 2 and the second shell consists of 8 and the third shell consists of 7. Here, since it is having 7, if any other element is giving 1 electron and it is attaining that electron, then what will happen? It will complete its octet in the valence shell. So, for any element, for attaining octet, it is either losing or gaining. So, here sodium is losing to attain octet configuration. Here chlorine is gaining electron to attain the octet configuration. So, you know that chlorine's is configuration 2, 8, 7. So, after gaining electrons, it will attain 2, 8 and 8. Hence, it will form what? Octet configuration. So, it will form a negatively charged ion. Okay. So, here you know previously when it is in a neutral atom, it is having 17 protons and 17 electrons. But after gaining 1, what is happening? 17 protons will remain as it is, because we know protons are never lost or gained. Then what will happen? The number of electrons are increasing by 1 unit, so it is 18 electrons, hence the negative charge is increased. That is the reason chlorine will attain negative charge by -1. So this is negatively charged ion, and that is an anion. So based upon the number of valence electrons, we can tell how it is being forming a cation, or will it form a anion. So this is how I can distinguish the into metals and non-metals based on the property of ions. So let us go to the next property. So discussing about the next one, that is formation of oxides. So metals on heating, that is on heating, they react with oxygen and they form metallic oxide. And for metallic oxide, respective metallic oxides, so if you are taking sodium on reaction with oxygen, it will form what? Sodium oxide. So this is a metallic oxide. Now oxides formed are basic or amphoteric. So what do you mean by this? Basic, most of the metallic oxides are basic in nature. Sodium oxide is a basic oxide. Now what is amphoteric oxide? Amphoteric oxide means the oxide which reacts both with base and an acid. So such type of oxides are known as amphoteric oxide. Whereas if you take basic oxides, basic oxide only react with acids, they cannot react with bases. So that is the basic difference between basic oxide and acidic amphoteric oxide. So amphoteric oxide example is aluminium oxide. Okay, so this is one of the example of amphoteric oxide, and zinc oxide is also amphoteric in nature. Now getting back into the non-metals, so the oxides of non-metals, that is non-metals on reacting with oxygen, they form non-metallic oxide. For example, sulfur on reaction with oxygen will give you sulfur dioxide. Right. So this is a non-metallic oxide. These non-metallic oxides are either acidic or neutral. So here if you are talking acidic means they react with a base. So this reacts with a base, sulfur dioxide, so it is an acidic oxide. Now what is neutral? Neutral means like carbon monoxide. Carbon monoxide is a neutral oxide of carbon, whereas if you take carbon dioxide, this is an acidic oxide, but this is a neutral oxide. So in that way, metals and non-metals both can categorize based upon the formation of their oxides into either basic or amphoteric in the case of metals, and acidic or neutral in the case of non-metals. So let us go into the next chemical property. So now reaction of oxide with water. So whatever oxides we have learnt, that how they are going to react with water, that we are going to discuss now. So we know that metallic oxides give bases on reacting with water. So metallic oxides are basic in nature. At the same time, there are two amphoteric oxides that we have discussed, aluminium oxide and zinc oxide. Now if I am taking one example, we will discuss about that. Similarly, if I am taking non-metals, so non-metallic oxides are acids, they form acids and on reacting with water. So they are acidic oxides, at the same time we are having neutral oxides also. So acidic oxides like sulfur dioxide that we have discussed, carbon dioxide that we have discussed, and neutral oxide like carbon monoxide. So what is the difference between these acidic oxides and neutral oxides? See, acidic oxides on reaction with water will form acids, but neutral oxides they don't react with water. So that is the difference. As we are talking about the bases, the basic oxides on reaction with water will form their respective bases, but if you take amphoteric oxide, since it can show a basic property, if I am taking aluminium oxide, it will form aluminium hydroxide on reaction with water. So here if you are taking the example in both the cases, so first one, magnesium oxide. So magnesium oxide, how it is formed? Magnesium on reacting with oxygen will give you magnesium oxide. Okay. So we are giving magnesium oxide. This magnesium oxide on reaction with water will give you magnesium hydroxide, which is a base. Similarly, there is amphoteric oxide also like aluminium oxide. Aluminium oxide on reacting with water will give you aluminium hydroxide. So it is also forming a base. So this is how we can categorize metallic bases, that is bases, metallic oxides into bases, and even amphoteric oxides also form bases. Now getting back into the non-metals, so non-metals usually if you are taking sulfur dioxide that we have discussed just now, on reacting with water will form sulfurous acid. Similarly, I have also discussed about carbon dioxide and carbon monoxide. So if I am taking carbon dioxide, this on reacting with water will give you carbonic acid. Similarly, carbon monoxide do not react with water, hence there is no reaction with water. This is known as what? Neutral oxide. That is why it is neutral in nature, it does not react with water. And also we are having two more oxides similar to carbon monoxide, that is N2O and NO. Nitrous oxide and nitric oxide. So these two are also neutral in nature. So this is about the formation of oxides and the reaction of oxides with water. So going to the next example, like another non-metal, that is chlorine. So chlorine when passed through water, you will get HCl, hydrochloric acid, and HOCl, hypochlorous acid. So till now we have discussed two non-metals which reacts with water. So phosphorus is a non-metal which does not react with water, hence it is stored in water. So how sodium, potassium, lithium are stored in kerosene? Because they react with water, and here phosphorus do not react with water, so it is stored in water. So discussing about the another chemical property, that is reaction with acids. How metals react with acids and non-metals. So talking about reaction with HCl first, hydrochloric acid. So if I am taking cold dilute acids, so usually active metals, you know what are active metals? So active metals like sodium, potassium, they react very vigorously and liberate hydrogen. So any metal on reaction with an acid gives salt and hydrogen. For example, if I am taking sodium on reacting with HCl, then it will give you sodium chloride and it liberates hydrogen. So salt and hydrogen. So active metals even with cold dilute acid also they will liberate. Similarly, if I am taking hot concentrated, so it normally reacts with cold dilute acids, and hot concentrate very vigorously they react. So active metals react vigorously giving the same products. Products will be same but the reaction will be very vigorous. That is the only difference. Now going to the non-metals, non-metals do not react with HCl. So now let us discuss the reaction of metals and non-metals with another acid like sulfuric acid. So when I am talking about sulfuric acid, let us first discuss with a cold dilute acid. So if I am taking cold dilute acid, active metals which are above hydrogen in the reactivity series usually react with cold dilute sulfuric acid to liberate hydrogen and also give the salt. Okay. For example, if you are taking the same sodium, so sodium on reacting with sulfuric acid which is cold and dilute, then it will give you sodium sulfate which is a salt and liberates hydrogen. Fine. But with the cold dilute acids, the metals below hydrogen like copper, silver, gold and all, mercury, they do not react with cold dilute sulfuric acid. Now going to the next one like hot concentrated. With hot concentrated, the metals, active metals, they react and they give sulfur dioxide. But these metals like copper, silver, mercury, lead and all, which do not react with cold dilute sulfuric acid, they also react with hot concentrated sulfuric acid to produce sulfur dioxide. So taking an example of one of the active metal, so like zinc if I am taking, if zinc reacts with the concentrated acid of concentrated sulfuric acid like H2SO4, then it will form its respective salt, that is zinc sulfate, plus it gives out sulfur dioxide and also water. Fine. So this is the difference between the reaction of sulfuric acid with active metals and normal metals with hot concentrated sulfuric acid and cold dilute sulfuric acid. So reaction of sulfuric acid with non-metals. So if you are taking some non-metals like I am taking here both carbon and sulfur. So these two react with hot concentrated sulfuric acid, and carbon on reacting with concentrated sulfuric acid will produce carbon dioxide, water and sulfur dioxide. Similarly, sulfur on reacting with concentrated sulfuric acid produces sulfur dioxide and water. So these are some non-metals which react with the concentrated sulfuric acid. So by this we have learned about the chemical properties of both metals and non-metals. So, I hope you understood the chemical properties of metals and non-metals. Now, let us discuss about the another category of elements, that is metalloids. So, what are metalloids? Metalloids are the elements which possess certain properties of metals and certain properties of non-metals. So, let us take some examples of those metalloids and discuss about them. So, here we are going to take about the metalloids and the property, the metallic property which it possesses and the non-metallic property. So, here we are taking first one is germanium. So, germanium is a metalloid. In the metallic properties, it acts as a semiconductor. So, you know, conductor is nothing but the metal had that property of conductivity, hence it is acting as a semiconductor at a high temperature, that is with the rise in temperature, hence this is having the metallic property. Now, going to the non-metallic property, so its oxide is acidic in nature, which will form acidic oxides, non-metals. So, that is the reason it is having a non-metallic property, that is it is forming acidic oxide. Similarly, another example like arsenic and antimony. These two elements, both of them are lustrous. So, the lustrous property is possessed only by metals, hence that is a metallic property, and they are brittle in nature. You know, metals are usually strong, okay, but the non-metals are brittle in nature. That is why brittle in nature, hence they are having that non-metallic property. So, this is how some elements possess some properties of metals and some properties of non-metals, that is why they are termed as metalloids. So, I hope you understood this category of elements. Now, let us discuss about the uses of certain metals, non-metals and metalloids. So, let us discuss the different uses of different metals. Okay. So, uses of different metals. Firstly, with magnesium, we will start off with magnesium. Magnesium is a metal which on reacting with oxygen, it burns with a dazzling white flame. So, hence it is used in the fireworks. So, you can see the dazzling white flame if I am just burning a magnesium ribbon, and also it acts as a very good reducing agent, hence it is used in the extraction of metals. Similarly, it is present in the chlorophyll of the plants. So, these are certain uses of magnesium. Now, going to the next metal, that is aluminium. So, where do you find aluminium? Aluminium foils and aluminium transmission wires. So, all these are nothing but the uses of aluminium. So, we tell that aluminium is used for making the body parts of the aircrafts and automobiles. So, it is not directly aluminium, but it is an alloy of aluminium, that is duralumin, which is light in weight, which is used for this purpose. Now, going to this, you know, this is nothing but aluminium foil, which is used for wrapping the food, right. Similarly, it is also used for making utensils and certain containers. These are also made out of aluminium. And you know, transmission wires, as we have discussed earlier, these are also made out of aluminium, because aluminium is a good conductor of electricity. See, aluminium is having that malleable property, very thin foil can be made out of it. That is why it is used in making the, it is used in wrapping the food, because it can sustain the heat, okay. And if you take the duralumin, which is light in weight. So, everywhere we are utilizing the properties of metals for different uses. Now, going into the next one, that is zinc. Zinc is a brittle metal that we know. So, zinc is used for galvanizing the irons. What is galvanization? Nothing but coating the iron nail with zinc, so that the iron will not undergo rusting. Hence, these are the galvanized iron nails, and it is also used in the batteries, like zinc carbon batteries for various sizes. These are of various sizes. So, these are some uses of zinc. Going to the next metals. So, what do you observe in this picture? Here is nothing but a picture of wires. So, these wires are made out of copper. So, we are going to discuss about copper, the use of copper. So, copper is used for making utensils, and we have the alloys of copper used for making different ornaments and also for making different idols, right. Similarly, it is also used in making the transmission wires, and here it is also used in making circuit boards. Going to the another metal, that is mercury. So, mercury is a liquid non-metal, mercury is a liquid metal which is used in the barometer apart from thermometer. So, you know the popular use of mercury which is used in the thermometer. So, apart from that, it is also used in the barometer. This is the use of mercury. So, let us go into the another uses. So, like titanium. So, titanium is a metal which is used in the joint replacements, okay, and also in the hip replacement. So here these parts are made out of titanium because titanium is inert to the human fluids. That is the reason it is used for this purpose. So the uses of noble metals. So what are noble metals? The noble metals which do not react with atmospheric air or water or even with the acids. So the examples of noble metals are gold and platinum. So let us discuss about gold first. So gold is a noble metal, and you know what are the uses of gold? First thing when we think of gold is the ornaments which are made out of gold. Apart from that, gold is also used for making the covering of the artificial satellite, main frames of the artificial satellite. So here you can see that the covering of the main frame of artificial satellite is made from the gold foil, and gold is highly malleable. That is also one of the use. Even though it is noble metal, it is highly malleable. That is the reason they are used for covering. Now you know this is gold. Apart from that, silver halides are used in the photographic plates. And silver articles, you know, silver is also used for making the jewelry and also articles. And silver foil. So silver foil is used to which is coated on the sweets, right? Silver is edible, that is the reason it is used in coating of the sweets. So now let us discuss the uses of non-metals. So looking at this picture, what do you understand about which non-metal I am going to discuss about? So the non-metal which is required for combustion is nothing but oxygen. So I am going to discuss about the uses of oxygen, and oxygen is widely used for what? Respiration, right? Without oxygen we cannot survive. That is one main thing. Apart from that, it has several uses. So few uses we are going to discuss. So first use is respiration, and second one, if you are looking at this picture, here the person is suffering with some respiratory problem. So for that they are giving her carbogen. So carbogen is a mixture of 95% oxygen and 5% carbon dioxide. This mixture is given to the patients who are having respiratory problem. Apart from that, oxygen is used in the welding purpose, like in welding, oxyhydrogen flame we call, where oxygen and hydrogen are combined, so which gives at very high temperature, so that it will burn the metal. It can easily melt the metal, not burn the metal, it can easily melt the metal. So that is the use of oxyhydrogen flame in the welding purpose. So you know the combustion use. So another major use is liquid oxygen, which is utilized for ignition of the fuel in the rockets, okay. And next one, it is also used in the blast furnace for the extraction purpose. So this is how there are some uses of oxygen, and apart from that, oxygen is also used for as an explosive for breaking big rocks in the mines, and it is used in the manufacture of certain acids like sulfuric acid and nitric acid. So several uses are there for oxygen, and oxygen is one of the important non-metal present in the atmosphere for the survival of mankind. So discussing about the another non-metal, that is hydrogen. So hydrogen is the lightest element, and because of that it is used in the weather balloons, and it is highly non-polluting element, like non-polluting fuel we can tell, but still it is not used as a fuel. The only reason is that the liquefaction of hydrogen is very difficult, storage is difficult, and transportation is also difficult. That is the reason it is not used, even though it is having high calorific value, okay. So this is some of the use of hydrogen. So discussing about sulfur now. So sulfur is used in gunpowder. So the mixture of carbon, sulfur and niter is nothing but the gunpowder. It is used as a gunpowder, and it is used in the vulcanization of rubber to harden the natural rubber for the purpose of making the tires and all. And it is also used as a insecticides or fungicides, because sulfur salts are used for this purpose. So these are some of the uses of sulfur. Going to the next non-metal, that is nitrogen. So nitrogen has wide variety of uses. Nitrogen is an inactive gas present in our atmosphere. Because of its inertness, it is used for many purposes, like it is used in the packaging of the food, so that the food doesn't get spoiled. You can see your chips packets where it is filled with certain gas. That gas is nothing but nitrogen. So nitrogen, because of its inactiveness, inertness, what happens? It will not allow the food to get spoiled. So similarly, liquid nitrogen is utilized as a refrigerant, and also used for storing the biological specimens. It is also used in filling the tires. Now going to the next talking about one more use of nitrogen. Nitrogen salts are used as fertilizers because nitrogen is a major nutrient required for plants. Similarly, we are going to discuss about another major nutrient required for plants, that is phosphorus. So, phosphorus is also a non-metal and phosphorus has certain major uses. So, when I think of phosphorus, the first thing which strikes into my mind is nothing but matchstick. So, matchsticks are made out of phosphorus, and phosphorus salts are utilized for making fertilizers. So, if you are taking white phosphorus is used for making the rat poison. As I have already discussed, phosphorus used for fertilizers. Apart from that, phosphorus alloy, that is phosphorus bronze, is used for making certain instruments. So, this is about the uses of phosphorus. Now, going into the uses of next non-metal, that is iodine. So, iodine is used in antiseptic lotion. So, tincture iodine, which is a mixture of iodine, potassium iodide and alcohol, is also used for cleaning the wounds and all. So, here this is one of the antiseptic use of iodine, right. Now, going to the next non-metal, that is chlorine. So, talking about chlorine is a poisonous gas. So, when I am taking chlorine when passed through water, I will get a acid, that is nothing but hydrochloric acid and hypochlorous acid. So, that we have discussed previously. Apart from that, because of its toxic nature, since it is very toxic gas, it is used for killing the microorganisms, that is in the purification of water, and also used for making bleaching powder. At the same time, chlorine is used for making certain harmful gases like mustard gas. So, these type of gases are used for just clearing the mop by the police people. So, this is how chlorine is used for different purposes. Now, going to the next one, that is silicon. So, silicon is used in the transistors, and silicon alloy is used for making the nails or certain things. Silicon alloy is used for making different items. So, these are certain uses of metals, non-metals, noble metals. Now, let us recapitulate whatever we have learned in our today's session. So, what we have learned, children, in today's session? So, today's session is completely about the properties of metals and non-metals. So, how we have compared them based on their physical properties, we have compared, that is upon the state and hardness. So, metals are usually hard and they exist in the solid state except liquid metal, that is mercury. But talking about the non-metals, so non-metals, they exist in both solids and the gaseous state, and if you are taking a liquid non-metal, that is only bromine. And talking about the hardness, metals are stronger and harder than non-metals, right. Talking about the melting and boiling point, metals are very high melting point. So, we have discussed about the melting point of iron, which is very high compared with the melting point of sulfur, right. Exception also we have discussed. So, low melting point like gallium. Gallium is an exception in metals with very low melting point. And you are talking about the non-metals, diamond. Diamond has very high melting point. It usually burns, right, without melting. Now, going to luster and sonorous property. Luster and sonorous both are possessed only by metals, but there is only one exception for lustrous and non-metals, that is graphite, and there is no exception in non-metal for sonorous. So, sonorous property is nothing but making sound, and that is possessed only by metals, right. Going to the next one, conductivity. So, conductivity is nothing but conduction of electricity or conduction of heat. This is possessed only by metals, and non-metals, there is an exception, like graphite is good conductor of electricity and diamond is a good conductor of heat. But apart from that, there are no other non-metals which can conduct electricity or heat. And finally, malleability and ductility. So, there is no non-metal which can be drawn into thin wires or into it can be beaten into thin sheets, like how you can draw copper, silver, gold into thin wires and beat them into sheets. So, this is the property of malleability and ductility. So, these are the physical properties that we have learnt and we have differentiated among metals and non-metals. Similarly, we have also learnt about chemical properties. So, in the chemical properties, we first discussed about the number of valence electrons. So, talking about the number of valence electrons, it is nothing but the electrons which are present in the last shell. So, if you are having 1, 2, 3 electrons, then they are nothing but metals, and if you are having 4 to 7 electrons, then they are non-metals. And then formation of ions. So, when you are having 1 to 3 electrons, then they lose and they form cations. So, metals form cations, and if you are having 4 to 7 electrons, they gain electrons and they form anions. Similarly, we have discussed about oxides. So, metals on reacting with oxygen form metallic oxides or basic oxides, and there are only like 2 examples that I have talked about, amphoteric oxide which have the both which react both with the acids and bases. Similarly, we have also discussed about the oxides of non-metals which are known as acidic oxides, and there are neutral oxides which do not react with water, that is carbon monoxide, nitrous oxide and nitric oxide. And we have also discussed about the reaction of these metals with water and acids. So, most highly reactive metals react vigorously with water like sodium, potassium, and based upon their reactivity with water, they are categorized into a reactivity series, and non-metals do not react with water, but we have seen that red hot coke on reacting with superheated steam will give you water gas. Similarly, chlorine on passage through water will give you hydrochloric acid and hypochlorous acid. Similarly, if we are talking about the reaction with acids, metals react with acids and form their respective salt and liberate hydrogen in case of HCl, and in case of cold dilute sulfuric acid also. But if it is hot concentrated sulfuric acid, then even active metals and the moderate reactive metals also react to give you sulfur dioxide apart from the salt and water. So, and if you are talking about non-metals, carbon and sulfur react with the only concentrated sulfuric acid, but not with the hydrochloric acid. This is how we have learnt about the physical properties and chemical properties of metals and non-metals, and we have also discussed about certain uses of certain metals, non-metals, and certain metals, non-metals and noble metals. So, I hope children you understood this session about the metals and non-metals very clearly. If you have any doubt, please go through the session once again, and thank you for watching.